All right, so in this lesson, we're going to start and really look at the anatomy of a line. So we're actually going to start, we're just beginning proportional relationships. So we're going to be studying proportional and non-proportional and how to graph them and how to read the graph, write the equation from the graph. But one of the key terms, so I want to make sure that we understand what a line looks like, or the slope-intercept form line, and it's broken into these different parts. So underneath, for example, you have your y. It's y equals mx plus b. I want to break down each part in this lesson. So the first thing, your y, that's your dependent variable. A lot of times you get that from, of course, your vertical change, or you're looking at so you're able to get that. Your m, we've talked about representing your slope, but also your rate of change. Now remember, your rate of change and slope are interchangeable terms because they really essentially mean the exact same thing. And then, of course, your x is your independent variable. Now, a lot of times a common mistake people make is they think the x value is part of the slope, but it's not. It's what's multiplied times the slope. So it's the slope, or the rate of change, times the independent variable. Now, as we start out with proportional values or proportional relationships, we won't talk as much about the b, but we will here very shortly. So let's go ahead and break down what does it mean. The b, it's your y-intercept. It's where the line actually crosses the y-axis. So that's something we want to pay attention to. And when we're working real life problems, we're going to look for some key terms here. For example, initial value, or a flat fee. And it's also a great starting point when I'm talking about graphing my linear equations. If it's a friendly number, it is actually, I look at it as the perfect starting point if you have a friendly number, and most times you will. But so that's the y-intercept. Again, we're going to start out with just y equals mx, and then we're going to work up to y equals mx plus b. All right, here are a couple of examples of various equations. Now, we're going to start with, actually, I'm going to go, the first one is it's not proportional, and I know we're not there yet, but you'll have an example to go by. First of all, you notice I kind of extended these lines down below your foldable because I want to break each part of the equation into the category where it goes, so you'll always have something to go back to, how to break it apart when we're actually working through. So for example here, so let's look at the first one. Y equals 2/3 x plus 3. All we're going to do is make sure, I just want to label each part. So here I want to look at the y. So if I have my y, because that's my dependent variable, and then I'm going to go ahead and put the equals, that's fine. My m, my slope, is the 2/3. Y equals mx. So I'm looking at 2/3 being my slope times the x, and then in this case the y-intercept will be plus 3. Again, this is not a proportional one, but nonetheless we will be there soon enough, and this is a great resource for you. So now the next one is a proportional relationship. It's one that we are looking at now. Remember now, a couple things about proportional: they're linear, and they have to go through the origin. They have to go through 0, 0. So in this case, again, y equals 2x. So we'll start with y under my category of y equals, and then I'm just going to have the slope, which is the 2. You notice the x is not part of the slope, but whatever that independent variable is, it'll be 2 times that, and then of course I won't have a y-intercept, so I will say no y-intercept. And I can actually write that, just help me remember. But remember, the letter that represents y-intercept is b, and you'll see that more often than not. But for your notes, that way you can see it. There's not a y-intercept, so you would just see it as written here as y equals 2x. And this is basically the basic makeup of a slope-intercept form linear equation.